curious, particularly, sorry, Mark Wasser, Journalism Institute. I'm curious, particularly with the example of, say, vaccines. What do you believe that maybe we can do to maybe offset the possibility of adverse publicity, particularly that framed by the goal of sinking potential threat at all costs?
So I think that gatherings like this are foundations of that kind of engagement. I think the more precision that this community can wield in describing safety threats in plain English, the more robust your ability to engage with the governments around the world who will have an interest in this technology and its impact on safety. I think that those are two particularly impactful vectors for managing those problems.
So I have a question off of the Twitter feed for Andy with respect to his parable of GMOs. And the question is from the Future Society. There's a person behind that, I'm sure. Shouldn't the political economy framework be considered as well, besides the risk framework?
Yes.
Ah.
Oh. So you do. There's a person behind it.
Sort of governments, and I very much like the parallel that you're drawing and the emphasis you're putting on the need for to understand civic epistemology. And I'll make it very short, but if the GMO case was also a question of economic safety, of farmers, let's say in France, who fear the arrival of a potentially predatory Monsanto, and if I draw the parallel now to AI and the rise of potentially monopolistic actors such as Uber or Google, don't we face a similar risk, and how should we address it? And that's why I mean by political economy framework.
I mean, political economy always matters, right? I mean, that's you know. So short answer is yes. I think, you know, as I prepared this talk and kind of refreshed my memory on kind of the experience with GMOs, particularly in the 1990s. There are a bunch of scholars who kind of looked at this with in some detail, and they considered the French farmer angle, and I mean, yes, French farmers were loud in the 1990s. I remember José Bové and sort of the protest movement. But I mean, let's not kid ourselves. I mean, France is not a country of small farmers. I mean, they have agricultural giants. They're just like we do here in the United States, and they have an interest in competing globally as well. And so, while yes, I think there is some producer interest. I'm not sure it's capable of explaining the sort of the depth and intensity of opposition to GMOs. It's a good question.
In the back, Greg.
For all four panelists, what application area do you think is like a safe area to kind of develop the confidence that's needed so that society will have it'll be a progressive adaptation and implementation of artificial intelligence? Clearly there's probably some areas, putting AI in charge of flying a plane maybe is not the right place to start. What areas would you say is a good place to start?
We already do it in a number of places, DARPA related to then applications within DoD. I mentioned one briefly in the talk, which is counter jamming or jamming of radars. And that's the kind of situation where it's serious. I mean, you really want it to succeed, but it's not, it's one step away from absolutely needing to rely on it succeeding every time. And there it's going to necessarily be better than what we had before. We have lots of examples like that you're using it in a place where it's very strongly sort of defensive. You want the defense to succeed, but you're not actually initiating a powerful action based on the AI.
I think one area is one that's low stakes, that involves human corroboration. One area where we invest is facial recognition. And there you have relatively mature technology. You have human operators who are able to assess the evidence as well, but also a demand from the human operator for auditability. So I think that's one low stakes area where we can start to build some of the tools that we need in order to inspire confidence.
I want to follow up on that, because we can make a distinction between AI applications that sort of expose us on the upside, but have a baseline that's pretty much established and safe, and other AI applications that are in fact safety critical, that if they were to fail or to have an accident, using the terminology of the paper, then we could actually have real consequences. I'm wondering if you see there's a continuum, or if there's a discrete transition to doing safety critical applications, and if so, regardless, what would be the first sort of safety critical applications that you might contemplate?
So again, I mean, we have stuff. We just recently launched a ship out of Portland, Oregon. It's currently down in San Diego doing mission trials. It's a completely autonomous ship. It can spend about 2 years at sea, and it spends its time going through sea lanes. It has to interact with fishing vessels, figure out how not to run down a small pleasure craft and things like that. So there's definitely a security critical application there. What's interesting about it is that it's on the sea is a simpler world than on the land, and so you can start to explore things in that context. So that's one of those that it's definitely is safety critical, but it's got a limited level of safety criticality.
My question, Claire Tomlin from Berkeley. My question was really yours, Bill, and I think that it's not really academia, but it's companies that are driving these land vehicles that are presenting safety critical situations. That I don't see what our ability is to what ability we have to understand until something bad happens what we can do at this point.
So without a doubt, we're going to get failure modes. I mean, my understanding is that the Google car at the moment manages about something like 16,000 miles before the operator has to engage in order to stop some sort of collision happening. And this is like an order of magnitude more frequently than a human driver, who apparently we all go about 160,000 miles before having some sort of collision. So there's some sort of measurable evidence that we're still, in some sense, an order of magnitude lower than we should be. But after all, even human drivers are not ideal drivers. We all have fundamental safety critical flaws in us, as the 30,000 deaths on the road each year attest. And so in the case of something like self-driving cars, it may be that we end up with a statistical argument that says statistically we've now improved over what human beings do. There are other situations where a statistical argument won't work. But in the case of self-driving cars, it seems to me plausible that it could.
All the way in the back.
On developing artificial intelligence, and getting there first can be an advantage both economically and militarily. How do you think of the balance between kind of going slowly and carefully versus going quickly and getting there first?
Well, I think we should go quickly and carefully. I mean, yeah, it's always a challenge. The reason that we have many aspects of the internet itself is insecure is not because there were not early designs for a secure internet. There were. It's that the one that took off was the one that was open and flexible and easy to adapt things to. And we see again and again a lot of the problems in cybersecurity. One of the program managers in my office says that the challenge is that we've been laying down sedimentary layers of insecure software. And I love that as a description of the problem that we've got into. And so, I mean, from a policy point of view, I don't know if there's a way to make sure that we don't do that with artificial intelligence, or whether we have to figure out, in some sense, how to live with it and how to adjust it sort of after the fact, in the same way that we are with more traditional cybersecurity.
Is sort of a cross between what Mr. Lunchbury said and Mr. Matheny. I was curious when we looked at manifolds and some of the explanatory models that you talked about, and limited data sets like that we might be able to use to rapidly teach machines. And then when we looked at what was said about the low probability and high cost issues, like maybe pandemic or something like that, that maybe, what's the balance between that and trying to make sure that we don't lose those critical pieces of data when we only have limited information for those systems? Does that make sense at all? I was just trying to wonder how do you strike those balance between that?
Sorry, can you distinguish data from information?
Oh, well, I'm sorry. I didn't mean to be inarticulate that way, but let's just say one example that comes to mind is like in Newtonian physics, we talk about limited data sets that told us that the planets had elliptical orbits as opposed to circular orbits. You know, there wasn't very many data points there, and a lot of times in science and statistics we tend to filter out the outliers when really they're very vital to our understanding of our issues. And I was wondering, in these systems, is there a way, what are we doing to ensure that we don't discount the outliers?
So I think in a lot of our research programs, what's rate limiting, I mean, what ends up being the bottleneck for the research is quality data sets. Either data sets about events, historical events, whether it's disease events, geopolitical events, cyber events, but also data sets about the characteristics of those events. And I think it is important to ensure that if there are outliers, is it because of a measurement error, or is it because that in fact is something that happened that was an outlier? I know, I mean, folks like Gary King have been looking at a lot at how do you measure whether something is truly an outlier and whether it should be included in a data set that you use to build a model. I think in our cases, we try to ensure that the outliers are preserved so that we try to model the phenomenon correctly, unless we're really certain that it was due to a measurement error. But I think the correction, I mean, for the research community is just to ensure that we have more better data sets. We probably end up spending tens of millions of dollars each year just on data in order to build better machine learning systems, just at IARPA alone. So finding a better method of creating high quality data sets that are shareable across the community in a way that's scalable is something that's important for us.
Let me add a different dimension to the answer, and I know that we're out of time. That there are times where we need to find in data things that are the black swan events, the very unlikely things. And so there the issue is finding the needle in the haystack when you don't even know if you've got the right haystack, or even if there's a needle in any of them. And so the challenge there is that what we've concluded is you need some sort of underlying model of what it is you're looking for. And it's sort of a little bit like how you do spread spectrum radio. How do you extract a radio signal when the signal is below the level of the noise? And you're in a similar situation here. You're trying to extract a signal that's below the level of the noise of the data. And so you need some underlying model of what that signal should be like. And then you can do things like convolutions and other mechanisms to be able to have that signal pop out.
So I think we're going to take our break. I'm sorry we don't have more time for questions. I want to thank, what an awesome set of speakers we had the first panel here.